Okay, so we're back to this little project here, which is going to be my one-dimensional Pong game, but hopefully with two little things to battle off against at the same time. So if you recall from the previous video, I was aiming to use a 4017. Oh, I lost the book again. Oh, here we go. I'm going to say, what a mess. Right, I was going to say, you don't have to get a copy of this book, because all of this is easily obtainable on the internet. So just Google, the best thing to do is to Google CD4017, and you're bound to find something that looks very much like this picture here. Same with CD4049, if you've watched those videos. So a few things that I have to talk about. So I kept thinking that the enable pin just enabled the output, but it doesn't. It just enables the clock, which is not exactly what I wanted. So we've got a few extra bits now, and we're going to talk a bit about how I was going to use the enable thing. But first, we're going to jump into this. So the idea is that this thing, because only one little light, this is very, very full of wires today, I'm sorry, it's all crazy. And the end result, of course, will be nice and hidden beneath some wooden enclosure. That's the theory. But anyway, let's just see it working first so that you know what I'm talking about. We're not going to plug it into the computer, because I was actually going to do some stuff with the computer sitting on the desk, but it just doesn't work. So let's just activate it. That's the wrong thing to plug it into. Here we go. And you can see I actually finished it all off. So now there's 16 LEDs, and they're all going through here doing their little business, going backwards and forwards just like I said it was going to. Which is odd, because the 4017 counts upwards from like 0 to 9 over and over again. It doesn't go backwards. So the first trick is, how did I pull this little trick off? And I can't remember what my exact hint was, but I think it was slightly misleading. So the idea is, we'll just bring up the little picture of the trip, I think, is the best way, and we're going to turn that off. This thing doesn't have an on and off switch. So we'll move that over there for a second. Though we could have powered it off that little USB power supply. So anyway, we have a reset pin on our IC, and we have a clock pin on our IC. So what we can do is we can just reset it back to 0. So it will reset the counter back to outputting a high voltage on pin 3, which is the 0 one. So it doesn't go in order, unfortunately. It's all a bit of a mess. And then we just pulse the clock the number of times that we need to get to whatever one we want. So if we wanted to get to the 5th LED or the 4th LED, so we'll start at 0. So 0, 1, 2, 3, 4th LED, which is the 5th one if you're counting from 1. Then we would pulse it, I guess, 4 times, right? Because if you're at the 0th one, you don't pulse it at all. But then you pulse the clock 4 times, and then you end up moving to the 4th position, counting from 0, or the 5th position, counting from 1. So you can just imagine, how many LEDs have I got? 1, sitting on the desk here. 1, 2. So we need 1 more LED. Oh, there's no more LEDs. We're all out. Oh no, there's one here. There's a couple here. There's another one of those with a bit of sticky stuff on it, and another blue one. So that's a multicolor one, that one. So say we reset it and we start here, and then we go pulse the clock once. So we go high and then low on the clock, and then we move on to here. So this one lights up, and then we pulse it again, high, then low. Then we get that one, and we pulse it high and low, and we get there, and we get there. So we can then, once we go back to there, but once we go back to the 0, we can go anywhere we want. And you might be thinking, well, that's a bit silly, because people will see you doing that. It's not going to look as smooth as it does when I have this activated, which is kind of true. Right, but the trick here, of course, is that this IC runs very, very fast, and your Arduino or Arduino clone is in this case, runs very, very fast in comparison to your eyeballs. So this is like 16 megahertz, and these things can easily cape up to like 5 or 6 or whatever megahertz. And so the point is, your eye, this megahertz means millions of things per second. We're actually doing this in a very tiny fraction of a second. So if you want to see it actually in slow motion, because I added an extra mode, so when I press this button, it's going to do two things, and we're going to get on to the next thing. We're going to get on to explaining the other bit, the other quirk that you're about to see in a second. But first off, we'll do it. So we're going to slow it down. So now you can see it's moving it up along to here, and it's actually going through and showing you, I don't know if you can actually work that out, but it's going up there, and then when it comes back down, it's pulsing back down there. So it really is doing this. So it's doing it over and over again. So now it's up to, and it's gone back down again. It doesn't quite look right, does it? Now it's going down, and then it's going back up. And this works. And you might be wondering why there are two LEDs on at the same time, and why are they matching the same kind of pattern? Well, because, so I'm going to cheat and disconnect it here for a second, but we're going to come back to those two things in a minute. Oops. Pardon me. The reason is this only has 10, this only lights up 10 things, so it only counts from 0 to 9 or 1 to 10, however you look at it. But I wanted more lights, and I actually originally thought I'd have to have 2 of these ICs, but I don't have to have 2 of these ICs at all. And so what this bizarre cluster of yellow wires is it's just pairing up these LEDs. So this one here is paired up with number 10. So we're always going to start counting at 0. So you're going to have to get used to that, because that's how computers work. So this is number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when we get to here, things change. So this one is paired up with a 0 one here. This one is paired up with a 1th one here, number 1. This is paired up with number 2. I feel like I should have a better pointer. Number 2, I forgot where I was. 3, 4, 5, and 6. So there's 16 LEDs on this thing here. So my counting's all strange. There should be 16, so I don't know what I've done wrong. But anyway, so they're paired up, and that's why when you see it running in slow mode, that there's both 2 LEDs going at the same time. So you're probably pushing a bit of current through here to do that, but it seems to be fine. I don't think it actually is a problem, because they're all going through the same resistor. There's only one current limiting resistor on this whole thing, and it's not even on this board. I don't think it's on the other one. Actually, there's 2 current limiting resistors, so that's actually a bad thing, because then it means it probably is sucking up a bit more current than the IC can take. It doesn't matter. Ignore what I'm just saying. We're only playing around. In the end, there's only ever one LED on at a time, but we can actually get it to, in fast mode, show both of them, or not. I didn't actually expect that to happen. Okay, I probably shouldn't do that. But I can disconnect one. So this one will only show, now it will only show the bottom ones, and this one will only show the top ones. So how did I do this little trick? Well, that's what the sorry. Okay, I have no idea why I'm coughing tonight, because it's late and I've been talking all day. Okay, so the trick here is that both these sets of LEDs light up, and I need some way to disable the other set. So basically, if I wanted to light up this LED here in particular, let's just turn it off for a second. This one here in particular, I'm going to light up its pair as well. So I'm going to light up these 2. So these 2 are going to be lit up. So this is number 1. So I'm going to pulse the clock until I get to number 1, starting from 0. So it's this one here. But this one here is also going to light up. And then I have to do a little additional feature to turn off this part of the LEDs. So the first 10 get turned off, but the second set stay on. But if I wanted this one to be on, then I still pulse the clock until I get to number 1 here, the same way. So technically, both of these are kind of like on, you can imagine. But I'm going to disable the second section, so you only see this one on. And that's kind of what happens. And the way that I did this, so because I originally had planned that I was going to use the enable chip on the enable pin on the 4017, and I thought what I could do is I could connect that up to the Arduino, and then I could either set that high if I wanted that particular 4017's output to be on, and to turn it low, or for example if I wanted it to be off, because I thought maybe that's how it worked. But that's not how it worked, because I wasn't paying attention. It's a feature I've never particularly used of a 4017 in my limited 4017 career, but now I have, and now I realize that it's not going to do what I want. So I used an arrangement. There are at least two possible ways of doing this. I did the slightly more complicated way for a strange reason. So what I did is I used a transistor, and I feel kind of bad because I was like, oh, I don't want to talk about anything that uses a capacitor because I haven't talked about them on my channel, and I'm using a transistor, which is the second time I've used a transistor in one of these projects, and I still haven't talked about them, so you just have to trust me that this works. And so in this case here, what is happening is we've got all our outputs from the 4017 coming out of here. So this is like a pin, and this is another pin, and this is another pin. This is not all the LEDs, and they're all going down to one thing, and there's this one current limiting resistor down here. But instead of going straight to ground through here, so if this pin was the on one, this would be like 5 volts coming out of the IC here, going through here, into here, down to here. But all the rest of these would be 0, so they would not do anything. If you didn't have this thing here. So you don't need this kind of sequence if you only have 10 LEDs. So that's a very poor way of blocking that out. We'll use this thing. That's even a worse way of blocking it out. Well, if that wasn't there, you know what I mean. We have Lego. So if that wasn't there, and that was black, and that went straight there, you don't need to worry about this if you've only got 10. Well, you do actually. That's not true. Ignore what I just said. You do, because you want to make it look neat and tidy. And you want to blank things out. So the other thing that I've done is when I'm counting it backwards and forwards, so when I start off and then I'm pulsing the clock as we go along, I am actually turning the LEDs off. So you can't see that, and then I turn them back on when they're in the right position. And so that's that. I don't know if it's going that fast, if that's that necessary, but I think it is, because you can kind of see it flashing really quick. Otherwise, what do we do? So we have this little transistor here, and the transistor, this is the base, and when there is a voltage that's significantly high and a significant current, enough current, then that will allow, so basically it's being used as a switch. So I'm switching on the current to go through here. So when this is on, we are syncing current to ground. And when it's not on, it's essentially acting like a open circuit, and so the current can't flow down to ground. So it's like there's a diode pointing the wrong way down there. And so that's kind of how it works. And so this thing is connected to another pin on the Arduino, and that's controlling these lights here, these LEDs. But the trick of doing this, of course, and I should have kind of drawn it on, is that there's one for each set of LEDs. So for the other ones, which are coming off here and going off, and so you can kind of imagine, we'll just do it for another one. This one has, so this is the second set, they're the red ones, and they're going off to their own little bunch. And down here there's another one, and I'm going to try and draw this backwards. That's the wrong way. Can't draw anything backwards here. Alright, that makes more sense. And I hope that kind of makes sense. So this one's going down to here, and that way if there's no path to ground, so when this thing is off, so when this is a low voltage going through here, when it's 0 volts down here, you can turn this thing off, and so there's no path to ground through here essentially, so this LED won't come on. But if this one is a high voltage, then this LED going off on this side will go on, and if they're both on, then the current will go through both LEDs and they both come on. So I hope that kind of makes sense. The other way of doing it, which might have been more sensible because it doesn't involve another transistor, oh no, I've gone and drawn on, that's why I don't like doing these things go straight through the paper, is to just use the output pin from the Arduino in the first place. So the output of that will either be 5 volts or roughly 5 volts and 0 volts or ground. And so these things here, so this is my output from my 4017, and they're going in here and they're going down here, and they're just going straight into an output pin. So one of these things on your Arduino, and that thing is either going to be 0 or close to 5 volts. Now if it's close to 5 volts, right, then if this is 5 volts and that there is 5 volts, there's very little voltage difference. So what matters is the voltage difference. So no current's going to flow. So 5 volts isn't going to flow into 5 volts, or at least there's not going to be enough of a difference to overcome the voltage drop you need for the LED. So even if that's 5 volts, it's not going to show up. The only tricky part is that if it's 0 volts over here, so if this LED is turned off because there's no current coming out of here because it's 0 volts, shouldn't say there's no current coming out of here. We'll just say that this is 0 volts here and this is 5 volts. Then you could say that the current will flow through this way into the pins that are actually off. But they won't happen because these are diodes and they point this way and they block that from happening, so that's not an issue in this case, though it could be in other cases. If you don't quite get what I mean, we're bound to talk about that again at a later point. But of course, if this is 0 volts, then there is a path from here. So if this was 5 volts and that was 0 volts, so you've set this pin to low, then there will be a path for the current to go. So there will be a voltage difference. So this will be high voltage. It will go through the LED, through the resistor, and down to here, and so the LED will come on. And the other ones will already be low voltage because only one of these is going to be high voltage. So these are low voltage. So in that case, there is no voltage difference because it's a low voltage here, it's a low voltage there. There's not going to be enough of a voltage difference to turn the other ones on. So in this case here, you would be setting this particular pin to high in order to turn everything off, and you'll be setting it to low in order to turn the LED set back on again. So you could do it that way. I haven't done it that way because I don't know why I didn't, and I just always feel funny when you're using the Arduino this way, even though I don't think it matters because these things can sink a reasonable amount of current, enough current to run one LED. So that's fine, and so the current's coming out of the 4017, so it's separate from the Arduino here. So it should work fine if you did it that way as well. So that's the other way of doing it. So the last thing I'm going to do with 10 minutes is go through the source code that I came up with to do this. But I'll actually show you the bits and pieces on the board. So these two wires are just for my slow button thing, but as you can see, I've only used 4 pins. So one of these pins goes to the reset on the 4017, one goes to the clock, and then 2 goes to each of the enable pins. These two I think are the enable pins for each set of LEDs. So one's for the first 10, and the second one is for the second 10, which is only actually 6 in this case here. And then they just go into here, and so these are the this is the transistors that I use. They're hard to see. They're 2N222s, very standard ones, and they're just going into here. So this pin is going straight into here, which is going into the base of the 2N222, and it's just going in there, and it's activating everything. And then you've got your LEDs. So these are all coming out of here, and then they're just being shared across, and this is just more wires going back down to the ground. And so in order to get it to work, I put this one into here. So this is the ground path for the second set, and I'm just going to use my original one over here. So that's the ground path. Oh, and I'm going to break it as I say this because these are terrible. Please don't break. I break these all the time. Oh, there we go. Okay. And so now it's back again working. So we're going to unplug it now. We've only got 8 minutes. So what we might do is I might make the talking about the code into a second video. So thanks for watching, and I will talk about the code for this part. And like, share, and subscribe.